Hi everyone, I'm Christina and welcome to video 17 of our A-Level Mathematics Calculus series. Here we're looking at stationary points and turning points, and this is part 1. So our objectives for this video are to define stationary and turning points. So let's first start with stationary points. So our definition here is that a stationary point is any point on a curve where the gradient is 0. So remember that our gradient is dy over dx for a point on a curve. So to find the stationary points of a function f of x, we first find the first derivative, f dash of x, and then we solve f dash of x equals 0 to find the x-coordinates of the stationary points. And then once we find the x-coordinate of the stationary points, we substitute those x-coordinates into f of x to find the corresponding y-coordinates. So let's look at a really simple example to illustrate all of this. So for y equals x squared minus 4x plus 21, you should recognize that as a quadratic function. To find the stationary point of this, we want f dash of x equal to 0, and then we can solve for x to find the x-coordinates, and then substitute those back into our function to find the corresponding y-coordinate. So to find f dash of x, we are differentiating y with respect to x. So dy over dx is equal to, we're going to differentiate each individual term here. So if we differentiate x squared, we get 2x. If we differentiate minus 4x, we get minus 4. And if we differentiate 21, we get nothing. So dy over dx is just equal to 2x minus 4. We equate that to 0. And then we solve for x. So hopefully you can see that I can bring the 4 to the left there, divide by 2. And so x is equal to 2. So that's our x-coordinate for our stationary point. All we need to do now is substitute this back into our function. So y equals 2 squared minus 4 times 2 plus 21, like that. So that's 4 minus 8 plus 21. So that's 4 plus 13. So plus 21 minus 8 is plus 13 plus 4. So here we get y equal to 17. So we have one stationary point here, and our coordinate for that point is 2, 17. Okay, so now let's make the distinction between a stationary point and a turning point. So as we defined above, a stationary point is a point where the gradient is 0 at a point on the function, but we don't know how the curve is changing at this point. So a turning point is a stationary point, but it's where the curve is actually changing direction. So a change in direction means a change in gradient. So we can say that all turning points are stationary points, but not all stationary points are turning points. And this depends on whether the gradient is changing sign on either side of the stationary point. So we're going to want to calculate the gradient on either side of our stationary point. And if we can see that those signs are changing, it means it's changing direction. And that would mean that it is in fact a turning point. So we're going to investigate this further in the next few videos.